Here we have problem number 17. So we have a professor is pushed up a ramp inclined upwards at 26 degrees above the horizontal. So he's sitting in a chair and slides on a frictionless rollers. The combined mass of the professor and chair is 87 kilograms. He's pushed 2.6 meters along the incline by a group of students who together exert a constant horizontal force. So when you're reading the question, it's very important that you read it carefully, because if you didn't understand properly the given task, then you may do it in a different way and you may get a wrong answer. So he says is pushed horizontally. Horizontal force of 500 Newton. It doesn't say that in parallel to the ramp or something like that. Okay, so it just said horizontal force. So the professor's speed at the bottom of the ramp is 2.4 meters per second. Find his speed at the top of the ramp. Gravitational acceleration is given. Okay, so before solving such a problem, we have to draw a free body diagram and appoint all these forces. First of all, we have a force which is pushed horizontally, okay, by a group of students. So Fs, which is force of the students, is 500 Newton. And then we have the weight of the professor, which is mg, and this mg is this angle. So therefore, it has to be resolved into two force components. One will be this one. One will be this one, which is mg cosine theta. Another one will be mg sine theta. Okay. Initially, speed of the professor was 2.4 meters, and it has moved a certain distance. At this distance, at 2.6 meters, you have to find the v final of the professor. Okay. Now, first of all, we know that the work is equal change in kinetic energy. Okay. Now, the work itself is equal F net times d. Okay. So F net here will be what? So F net will be the force component. So if you have this force which is pushed by student, this should be resolved into two components. One will be this one, which is F cos S cosine theta. Another one will be this force. Basically, this force, we don't need it because object is moving only in this direction, so therefore we are interested only on these forces. Okay, so F net basically will be Fs cosine theta, this one, minus mg sine theta, which is this one, force done by gravitational force. So by doing so, Fs cosine theta negative mg sine theta multiplied to d gives you this work. Okay, and that's equal to change in kinetic energy. So first of all, let's calculate what is the total work done on this professor. So you plug the numbers, and then you multiply it, and you get the total work which was done by all forces is equal 169.6 joules. Now the change in kinetic energy is equal to the mv final square divided by 2 minus mv initial square divided by 2. Okay, from there we have to find what is the v final. Okay, v final will be these two, both of them will go and multiply to here to work and divide by mass plus v initial squared. That gives you v final squared. So final formula will be this one. By plugging the numbers, you will get that v final at distance of 2.6 meters will be 3.2 meters per second.